A system of linear inequalities is sometimes also called a linear programming problem. In the IGCSE Math course, this is probably one of the most interesting things in the algebra unit. And while in the 0580 course, the students are not allowed to use a graphing calculator, and in the International Math course, the students are allowed to use a graphing calculator, they both are equally fun and equally challenging. In this particular video, I'm going to give some tips and suggestions on how to use the graphing calculator in a question such as this, and what kind of things you should be careful of at the time of the exam. I'll make another video for 0580 how to solve the same kind of questions. So if this is something that interests you, stick around. I'm just going to assume that all of us know some of the basic ideas of formulating inequalities, and so we'll jump straight right into a question something like this, where it says Ali buys X bushes and Y lavender bushes, X rose bushes, pardon me, and Y lavender bushes. So it clearly means that X and Y denote natural numbers, number of rose bushes and number of lavender bushes. The question goes on to say that he buys at least X rose bushes, at most 8 lavender bushes, at most 15 bushes in total, more lavender bushes than rose bushes. And we got to write down the 4 inequalities that represent this information. So at least 5 rose bushes, that is X representing the number of rose bushes, at least, that means X must be greater than or equal to 5, at least, that means 5 or more. At most 8 lavender bushes, that means Y has to be less than or equal to 8. That's a maximum you can have. At most 15 bushes in total, that gives us X plus Y must be less than or equal to 15. And more lavender bushes than rose bushes means Y must be greater than X, okay? More lavender, it says very clearly, so we're not saying Y is greater than or equal to, we're just saying Y is greater than, okay? Now, on the grid, show the information in part A by drawing 4 straight lines, label the region R where all 4 inequalities are true. So we're going to switch to our graphing calculator. And the first thing that we see is that we have to add a graph page. By default, the graph entry line comes as f of x, or f1 of x in this case, as a function. I'm going to try and introduce another method. Just hear me out first. Why it's simpler this way? Because, you know, in our courses, first the students are not directly taught about the function notation. F of x becomes a little confusing. Maybe towards the end of the year, as they're ready to take the exams, as students are ready to take the exams, they'll be comfortable knowing which one to use where. But at the start, when you're teaching algebra and, you know, some of the graphing features, perhaps they may not be so aware. So it's better to use this technique, which means you go to menu and graph entry edit and use the second option, relation. The advantage here is that you can enter the graph the way you want to. So the inequality we're looking at, the first one is X is greater than or equal to. We'll find the greater than or equal to under control equal to. X greater than or equal to 5 is the first inequality. You can see that, you know, the region X greater than or equal to 5 is automatically shaded. And like I said, I'll be doing another video where I will teach you how to determine which side of the line. X is equal to line, X equals 5 goes through the 0.5 on the X-axis, but they've shaded the right hand side. That's probably easier when it's a vertical line or a horizontal line. But when it comes to a line that's neither vertical nor horizontal, you know, slanting, how do you determine which side of the line determines greater than or equal to, less than or equal to? Some other video, some other time. But this time, let's use the calculator, and, you know, we'll go with the calculated shades on the right hand side of 5. So that should be X greater than or equal to 5. Second inequality is Y less than or equal to 8. So I hit tab to get that previous entry line again in the relation mode, that is Y less than or equal to. So I go with that, less than or equal to 8, and there I get, and obviously I'm not able to see Y less than or equal to 8 because my window settings max up to 6.67. So let's try and change that. You know, at the time of the exam, students are required to draw on the grid that's provided, as I said before. There they would have given you the window settings, all right? So accordingly, you manipulate window settings, okay? So I'll do the faster way. Either way, you can either go to menu and change the window settings here. I'll just go to this point out here and I'll make this negative 20, because this video is not so much about, you know, the window settings. This is more about, using this optimal conditions. We'll just go to that. So there we can see y less than or equal to, that's a red region all below 8 and the blue region greater than or equal to 5. And you can see clearly that the common region of these two inequalities alone is that red region out here, or, not red plus blue, almost purplish, or whatever that shade turns out to be, the common region there. The third inequality is x plus y less than or equal to 15. So we hit tab again, once again, x plus y less than or equal to, so control equal to will give you all those options, less than or equal to 15. I hit tab, I get a graph in black. Now, no discrimination about the color black, okay? So if you are okay with the color black, leave it there. And black color also matters. But if you want a different color, you can just go right click and, change the fill color to, let's say, something like green, okay? So right click on the handheld is control menu. Hit control menu, you'll get the right click options. So you got the three inequalities. And now when you're looking at the common region between, for all these this region out here, right? This region out here. So from this point to this point, to this point, to this point, there you go. That's the common region. It's getting darker here. So what I'm going to do is I'm just going to zoom that region, bring it, center it a bit more. There you go. Okay, so that was the line x plus y equal 15. So on this side of the line is being shaded. So common to all the region is that region here. Okay, but remember we want not just this region. Actually, it goes even, it should go even below, right? Because it's y less than or equal to, and then so all of that from here, and all the way down here. So there's no, seems like it's no lower bound. But let's look at the fourth inequality, which is y greater than x. So I hit tab and I say y strictly greater than x. That sort of puts a bound to the low. Otherwise it would have gone all the way down. So that magenta region. So now we've got this region out here, and that's the common region. That's y less than or equal to 8 below the red line. That region out here, that four-sided quadrilateral, we've got 1, 2, 3, 4. Yeah, four-sided. What I'm going to do is that I'm going to highlight the region by going to menu, geometry, and create that shape. It's a polygon, and I'm going to join that intersection points. And there you go, that point, and I'm going to create a polygon. Now, I'll tell you why I like this method, okay? And since it's good to highlight the region so that it'll stand out, I'm going to fill that with some bright color. That yellow region is our common region for all the inequalities, okay? So it's like the optimal region where you can find all the optimal conditions. And if you go back to our question that we were looking at, it says rose bushes cost $6 each. Lavender bushes cost $4.5 each. What is the greatest amount, a maximal idea? $6 each. So if I were to just write down cost as in terms of x and y, x, remember, was referring to the number of rose bushes. So the cost would be 6x plus 4.5y, all right? Because 6 for rose bushes and $4.5 for y bushes. So that's the kind of the cost function, if you were to call that. And we want to find out the greatest amount of money that Ali could spend. The greatest cost possible. And for that, we're looking at the optimal conditions here. All the inequalities seem to create a boundary at this region. Okay, so that's like your optimal conditions here. Okay, in some examples in economics, you can even think of minimizing the cost, okay, or whether it's maximizing the profit or something, so we use the word optimal because all the optimal values would be found in this particular region. Cool. So I go back to my graph, and the first thing I'm going to do is that I'm going to try and get the coordinates of those points, the intersection points. There are many ways to get there, but I'm going to show a very fast way. So menu, actions, coordinates and equations, and if I just hover around the point A, it'll show me 5, A. I click that and then position it somewhere. Hover around B, get 7, 8 for the coordinates of B. Do the same thing for C, click somewhere else so that I get the coordinates of C and the coordinates of D. Now this is important for us to know how to get the coordinates of each of those points, which are valuable information, all right, because they are on the borders. Not only they are on the borders, which are defined by these inequalities, but they're also the corner points. They say that it'll not go beyond those values. So you've got 5,8, 7,8, and every other value in between is going to be either less than 5, less than 5,8, and this is a slanted line, so it's 7 here and 7.5. So obviously the integral value, maximum integral value is 7. And likewise here, you've got the maximal integral value for x is 5 out here, or the minimum, because it's going up on the side. So that determines the region, and these points, these vertices of this polygon, this quadrilateral, are important points. So let's consider those points to give us the cost. So I have 7,8, 5,8, 7.5, 7.5. I'm going to exclude 7.5 and 7.5, this C. Okay, the coordinate C, I'm going to exclude that because, remember, let's not forget what our question was. Our question was that X and Y are referring to the number. I highlighted that before, the number of rose bushes, the number of lavender bushes, which means you can't get 7.5 rose bushes, right? So algebra, we saw all the algebra, and this is probably, that is why I like this topic so much, because when it comes to this kind of application, you have to decide X can't be 7.5. Yes, we have a value, but when you're using the value, you can't use X is equal to 7.5. You got to make up your mind. And some questions, where you can use, you should use, and you will have to use. In this particular case, of course, you can't use 7.5 and 7.5. I think C, the coordinates of C was 7.5, 7.5. So the only three values that we can consider, the integral values are 5,8, 7,8, 5,5. For those values, let's try and figure out what the cost is. And I'm going to use the calculator page this time. So I'm going to hit Control Doc to add a calculator page. And I'm just going to say, this is 6 times X plus 4.5 times Y. That was my cost function. So I have 6 times X. I'm going to use the first one. It was 5,8, right? So 6 times 5 plus I have 4.5 times, so this is for 5,8. I get the value as 66. That's $66. I'm going to just back up and bring the previous entry. I'm just going to change from 5 to 7 because the next coordinate of B, as you can see, was 7,8. So that makes it 7,8. That's 6 times 7, 4.5 times 8. And there I get 78. That's greater. I'll go back, and I think the third coordinate we are going to consider is for the coordinates of D. We are going to ignore C, as I told you why. D is 5,5, and intuitively you can tell that it's going to be less, but let's just verify it again using the calculator. So that's 5 here and 5 here. Hit enter, 52.5. We are going to just make a note of all these things, and that will help us conclude what the maximum or the greatest amount is going to be. So I'm going to write that using or 7,8 would give us 6 times 7 plus 4.5 times 8, and that is 78. And that when you compare as working, I think it'll be a good idea to just include the other ones also. So 5,8 is going to give us 6 times 5 plus 4.5 times 8, which gives us 66. And 5,5 is 6 times 5 plus a 4.5 times a 5, which gives us 52.5. And obviously you can see that that is the greatest amount. And so you can say that the greatest amount of money that Ali could spend in this scenario is $78. Okay, that should be the correct answer. And you've shown you're working, and I think you should get the full credit for that. So this is how you solve a question like this using the graphing calculator. However, after you've done the unit of functions, and by that time you'll have known a lot more features of the graphing calculator, you'll have to change your technique. And so this part of the video is equally important. All right, so the first part of the video is when you're first learning and you're still trying to understand how to plot and using the points of intersection and all those kind of stuff. But after you've done your function, this is important. The unit on function, this is important. Now, why am I saying these things to you? Why is this part of the video important? At the time of the exam, whether you're an IB student or whether you're an IGCSE student, you have to switch your calculator to an exam mode. In the TI Inspire, it is known as the press to test mode. And in the press to test mode, some of the features get locked. Okay, I advocate CAS. I always use CAS because it's great learning stuff. But this method of entering the inequalities or even equations using the relation method gets locked on the calculator. Okay, I'll tell you what I mean by that. So if I switch to the calculator menu, and let's say it was the time of the exam, all right? So right now my calculator is not set to exam mode, all right? But what happens is if I go to menu, graph entry edit, this option, it will show. It will show. It doesn't show grayed out, okay? This is tried and tested. You can try it out on your own. It will show, but when you start typing and when you hit enter, it will say that it's locked. All right, so you cannot enter an equation or an inequality using the relation entry mode at the time of the exam when the calculator is set to press to test mode. So you need to know another way to enter it. That's number one. The part that I found it really sad that gets limited, that also gets limited is, I went, when I graphed, I found the points, those 5, 8 and 7. Do you remember how I found that? I just went on menu and I showed actions and I hit coordinates and equations. This number 8 gets grayed out. So when you are in the exam time and the calculator is set to press to test mode, remember these two things. You cannot find the point of intersection using this option. Those A, B, C, D, those coordinates are the points of intersection, okay? So it's kind of a bummer that you cannot use these features at the time of the exam. So the two things, don't forget, you cannot enter the inequalities using the relation mode, and you cannot find the point of intersection directly using that menu actions and equations and coordinates. These are very powerful features. So what we're going to do is that we're going to try and do the same question on a different graph sheet as it were in the press to test mode. So I'm just going to jump straight to the question first to try and rewrite those inequalities in the functional notation. Now, I must say, all right, x greater than or equal to 5, you cannot enter it. You cannot enter it in the calculator in the press to test mode because the relation mode is turned off. All right, you cannot. You tried, meaning you enter it. It's just when you hit enter, that time it gives you the message saying press to test mode. And because sometimes there are two ways that the calculator works in the press to test mode. Sometimes it's grayed out. Like I said, that for the coordinates, when you go menu actions and the coordinates and equations, that's grayed out. I mean, at least you know that it's not going to work out. But this one, when you're entering the relation, it's on, and you enter the inequality, and it allows you to enter the inequality. And when you hit enter, then it says that there's a restriction, a press to test restriction. So I find it very strange. Maybe I'm missing something. Maybe some of you who have cracked this, let me know. Okay, in the comments, let me know. Or just write to me and let me know if you found another way to enter inequalities such as x is greater than or equal to 5. Because according to me, I've tried it and I could not. So, that means that students will need to know how to graph x is greater than or equal to 5, as it is not, you're not going to be graphing on the calculator on the grid that's provided to you. So you need to know that, if there's a grid given to you, wherever you have marked out 5, wherever you've marked out 5, x greater than or equal to 5 is just that line, the vertical line, and students still need to know that which part of the region is greater than or equal to 5. So there you go. All I'm trying to say is that this will not work in the press to test mode. Y less than or equal to 5, 8 will work, but you got to write y as f of x. Okay, so this is just to help those who have not yet done functions. So it would be f of x is less than or equal to 8. The next one should be written in terms of y. So you can write this as f of x is less than or equal to 15 minus x. And this will be written as f of x is greater than x. So these three inequalities you can enter. I just want to show that quickly. And then how to find the point of intersection. I'm sure you probably know, but we can run through it at least once. And the other point of intersection, you can do it and then complete the question as homework. So let me quickly show on the calculator how to enter it using the function entry. So by default, you should get the function entry. But again, because these are not, let me just make this 10 and let me make this -10 here, the window settings. So I go to the function edit. It's still on the relation mode here. So let me go on the function. So it's menu, graph entry edit on the function entry line, I'm going to enter f of x as less than or equal to 8. One way to do is that if you hit the delete key or the backspace key, it will give you, those entry. Even here, when you see number 6's relation, it won't allow. You can try it, okay? So y is less than or equal to 8. So I've got y less than or equal to 8. And if you notice, the moment I said it quickly gave the relational entry mode, okay? In the press to test mode, it's going to allow you. So as you saw, the moment I hit y, f of x is less than or equal to, it gave me the entry line. But I tried it and it works when I do y is less than or equal to. But because when in that inequality where there was only x, like x greater than or equal, there's no y term involved, it won't let me. It won't let me. But like I said, if you have a workaround, let me know. So I'll hit tab again to give this relation. But again, I want to show that, you work around with the f of x. So you go to menu, graph entry, f of x, and f of x, the next one is less than or equal to 15 minus x. So the moment if you don't want to do the backspace, you can even go to this control enter to give to get the inequalities. But the moment, because it's f of x is equal to, I have to hit the backspace and get the less than or equal to, or whichever inequality I need. In this case, I only need less than or equal to. The moment I hit less than or equal to, watch, it goes to the relation mode. Watch this. Can you see that? It gives me the relation entry mode. And it will work in the exam, by the way, in the press to test mode. So y is less than or equal to 15 minus x. I have no idea why this works, but not with x. So I'm trying to find another way to do it. If you are successful, let me know. I haven't been able to get this thing to work. So there you go. It shows the other equation. So what I'm going to do is that I'm not going to go through the whole thing because the video is getting really, really long now. I'll just show the point of intersection. So for that, you can just go on menu and I can use analyze graph and find the point of intersection. Or you can just go to menu, points and lines, and there again, there's this another option to find the points of intersection. I like the second one approach better because if there are two graphs with more than one point of intersection, then this is one shot will give you. You just have to select this and select the two graphs. And the moment you've selected the two graphs, the point of intersection will appear. So in this technique, by this way, you can find the point of intersection, which was easy in this technique. But to solve the question, you need to get those points of intersection, all right? As we did in this, you need to get the point of intersection. So what did we do today? We saw how to enter the inequalities on the graphing calculator, okay? I showed you the technique that you can use when you have not yet done functions, because students will not understand f of x, okay, at that point in time. So that is the reason why I encourage that user relational mode. They can go x plus y or x plus 2y, whatever the equation is, the way it is given, or whatever the inequality is, the way it is given, and let them first learn the idea of inequalities. Then when they've done functions, you can teach them how to do it, because as I said, at the time of the exam, when the calculator is set to the press to test mode, there are certain things that you cannot do. I want to know what you think about this video. If you have other ways to do this, please mention in the comments, okay? Also, if you like this video, please hit the like, comment on it, subscribe. I'll make more videos and give me some ideas. Give me suggestions on topics that I can make more videos to make the learning of math fun. Thank you so much.